Yeah, so it's really nice to be here to explain my experience, my background, and then also what we're building here in Switzerland. And really what I want the takeaway to be at the end of everything is that it's better to do anything, it's better to do something rather than do nothing. And so, as was briefly mentioned, I'm from a very remote part of northern Canada. To take this, my town has about 2,000 people in it. The nearest village, or the nearest town, is about the distance from here to Zurich. And then the nearest city would be from here to Munich. And so this is roughly all just wilderness in between this area. And so one of the first positions I had in this remote part of Canada was leading a ecological sustainability team for the Ministry of Natural Resources. And what we would often do is we'd go into the wilderness with a canoe and we'd collect waste, essentially, from people that were traveling deep on a canoe, doing nature things, but leaving waste behind. And so from very early, we realized that there's just the waste problem everywhere. There's this plastic problem, and it needs to be solved. But one piece of waste that was also common where I'm from, which we don't think about as much, was in fact much bigger plastic waste. And in northern Canada, this would often be boats or canoes that would be abandoned somewhere on the lake. This photo here is actually from Florida. So right now, also in the United States, in Canada, in France, in the UK, a lot of places, what they do is they just take a boat and they abandon it on shore somewhere because there's nothing else to do with it. And these boats are made of a composite plastic. So this is a fiberglass composite plastic. It's a big chunk of plastic. You float in the sea, lasts about 50 years. After this, it's waste and there's nothing to do with it. So we're trying to figure out how do we solve this problem. There's a bigger collection problem than there is with plastic bottles because they're big structural pieces of plastic. And there's better problems with just how do you treat this type of material. And the problem is people have tried various methods for the last 20 years to deal with the waste coming off of this. And the problem is it could never be profitable. And so after I finished my position in Northern Canada, I went on to do a PhD in physics. I eventually moved to Switzerland. I did a postdoc here at EPFL, had some startups after that, and then I met with my partners here, Guillaume and Pascal. And what they were trying to solve was how do we recycle these boats? How do we do it profitably? And so what we were looking at was this, how to recycle composites, and we realized it wasn't just boats. This is actually a massive problem. So if you think about nice clean energy, you think about wind energy. But the wind turbine blades are in fact also made of glass fiber composites. And so people will tell you that 80% of a wind turbine blade is recycled, and this is true, this is the metal part of it. But all the blades, when they take them down and are decommissioned, they just get buried. There's millions of tons of this waste being produced every year, and millions of tons of this leaching toxins into the environment. And so what we needed to do is we needed to find a way to separate this plastic from the glass fiber in a way that we could do it profitably. People have been able to do it for 20 years, but it was never economically feasible. The problem in our society right now, if you can't do it in an economically feasible way, you don't do it. So we looked at what are the problems? Why can't people do this? Well, the process we use to remove the resins, in fact, you need heat, which usually takes a lot of external energy. The typical machines that would do this process, which is pyrolysis, they would use this for tires, they'd use this for other types of waste. And it takes a lot of energy, and you have to grind up the material. It tends to go into this big rotating drum. And if you do this, you destroy the glass fiber, you get a pyrolysis oil out, and you can sell the oil, but the value of the oil is quite low compared to the amount in the process. And so everyone was losing money, so they continued to just dump this material in landfill. Boats, they would take them out into the Mediterranean, drill a hole, sink it to the bottom of the sea. Or, as anyone knows, in Switzerland here, if you're trying to get a new boat and get a mooring space, there's none, because you just leave your boat there. There's nothing else you can do with it. And so the wonderful thing about Switzerland is it's really easy to get a very vibrant amount of research money early on that helps you build companies. It's a really great place to make a startup when you're trying to figure out how to do something new. And with the EPFL here, we found a great research collaboration to say, what do we need to do? We need to make it so that the fibers can be resold. We need to do it in a way that the fibers can be sold, that we can make a profit doing this. So one of the things we did is we designed a reactor that we can have a full piece of this material in rather than grinding it. When we do this, we preserve the length of the glass fiber, so we're halfway to being able to sell it for a good price. The second thing is that it needs to retain at least some of its properties. So often, if you put it in a big oven, then maybe the properties of the glass fiber would be reduced standard to 20% to 50%. And so at this point, the market doesn't want to buy it anymore because they can just buy the new stuff for relatively cheap. So then we needed to find a way to preserve the properties of the glass fiber as close as possible to virgin so that they could be accepted for new products in the market. And so this is what we developed here. Actually, so the first funding we got was the E4S Tech for Impact grant. So this, we were able to hire a postdoc here at EPFL to then develop a post-processing onto these fibers so that they're now sellable. We had to make a few sacrifices. So this is trading off. One, we had to find market partners, industrial partners, that were willing to accept not a perfect product. They were willing to make a compromise on the structural strength in order to use a recycled product. But luckily, we're in a situation now that a lot of people like to do this. The second thing we needed to do is we needed to make it energy efficient. In order to do this, we decided we weren't going to try to maintain the resin. We weren't going to try to make resin to resin, and this is something that policy still needs to work on. So here in Switzerland, for example, a lot of the recycling policy favors non-depolymerization. That means that you try to keep plastic in its current form rather than breaking it down into smaller pieces. In the process we use, we break down the plastic into a smaller piece that has to be remade back into plastic. And government policy still doesn't like this, but we've been pushing now with some of the changes in the law recently here, and also with the inclusion of new plastic credits, that they can favor processes that allow the depolymerization of plastic and then the repolymerization of plastic as a legitimate way to recycle plastics. And the last thing we needed to do is we needed to make it energy neutral. So we decided what we were going to do was we were going to sacrifice some of the volume of the material. In this case, it's about 5% of the volume. And this becomes then a combustible gas, and this powers the entire reaction. So we can now recycle these materials profitably, we can sell the output materials, and we can get as close to possible as virgin materials so that the industry will actually accept us recycling these materials. And yeah, so that's basically my talk. That's what we needed to know was that we needed both industry, both government, and technical compromises in order to get a product that would hit the market and be accepted. Thank you.